So, there's this ethical question about whether book burning is okay, but we're just going to take that and throw it to the side because today we're burning papers, which might be wrong, but something about it is just so right. It looks so good, it's completely procedural, meaning everything's driven by nodes in Blender, and now that I've done the best intro ever, that's not going to let you leave, I guess we should just begin the tutorial. So, today we are covering paper burning, that's right, and this is just a plane, and everything else is completely driven by nodes, meaning that, you just click play and it does the paper burning. So, I mean, it's not the best looking effect in the world because I didn't spend that much time on it, but it's a very, very good base, and let's talk about all the control we have. So clearly it's wiping from side to side, but what if I told you we can control the angle of the burning? So now it can go from this side to this side, and you can change that as it's happening. You just don't want to pick a value that's too low. You can rotate it. You can control kind of the quality of this burning, so you can make it look kind of like a line or very, very scattered, and you can see it kind of works with the burning, and there's a bunch of other stuff we can control, like the brightness of the fire, etc. But I think we should get into this tutorial, which, warning, some of it might be a bit advanced if you're not used to nodes, so stick around and maybe learn some advanced stuff. Okay, so what I'm going to do is I'm going to start a new project. I'm going to be using version 2.83, but I think 2.82 should work. Actually, no, vector rotate node. Use 2.83, which is now the main version, so I don't know why you wouldn't be using it. Okay, cube. Get rid of it. I'm going to replace it with a plane. Why? Because planes kind of look like paper, and they look even more like paper when you resize them like this. And yeah, that's the modeling. We're already halfway done with the tutorial. Congratulations. Halfway done. Next is everything that's left is just nodes, so you've already done a lot of the work. Okay, so how are we going to make this material that has the paper, has the burning, it goes from side to side, it's procedural? Well, it's a lot to think about at once, so I say we take it step by step. So first of all, make a material. I'm going to call it paper, and I think first order of business should probably be making this look like aligned paper. To do this, I'm actually going to use a image texture that I downloaded on Google Images. It's free. Just go to Google Images, type in lined paper, download something. That's what you're going to use. So image texture node, plug that into the surface. And then for the texture, I'm going to use, where is it? Oh, I got some weird photos here. We're just going to use paper. And you can see that the texture is mapping correctly in terms of orientation, but there's a big gap at the top and bottom, and that's just because of the nature of the picture. But we can fix it because right now this is by default using UV coordinates, meaning it's using the UV map. That's what it means. So we just open up the UV editor for this object, and you can see that we can just kind of manipulate the UV like this, which if we have both at the same time, you can see how that's affecting everything. So let me just do that again. This is affecting the UVs live. That's the idea. So I'm just going to shrink this down a bit more. And yeah, it's not perfect, but who is perfect really? Maybe scale it just a bit. Okay, cool. So now we have our paper. Maybe yours has holes. Maybe yours is like grid paper. It really doesn't matter. Just the point is image texture node, and let's save. Wouldn't want to lose all this beautiful progress. Okay, so we've done this. I think next order of business is we have the paper, and now let's make the burning line going from side to side, which later we can rotate in all this. So to make a line going from side to side, if you've seen my laser tutorial, it's pretty much the same idea. What we're going to do is we're going to use texture coordinates, and specifically we could use generated. We could also use object, but what I would recommend is using UV. Because the nice thing about UV is that it kind of deforms with the geometry, like it sticks onto it as if it's a texture slapped on. This is why UV coordinates are nice, and we can separate them by X, Y, and Z components, really just X and Y, because UVs are just two-dimensional entities. You can see with the X separation, we have a gradient going from left to right along the X-axis, 0 to 1. Y-axis, this way, and really we could use either X or Y for this. I'm going to use Y because it seems a bit more natural for this to burn from bottom to top than left to right. Okay, so how do we make the line? What I like to do, math node, set it to compare. So right now we're feeding in Y values to compare. Let's give it a bit of epsilon, and I go on this spiel a lot, so let me just quickly describe what's going on here. The reason this makes a line right here is what it's doing, what the compare node is doing is it's taking Y and comparing it to 0.5, so input 1 compared to input 2, so we're saying how close is Y to 0.5 with a threshold, a distance, a radius of this epsilon. So again, this is just saying make it white wherever Y is within 0.02 distance of 0.5, meaning you make this bigger, it's going to take up more area because more of those points qualify, and if it's 0, no points qualify. And the other thing this means is that this value, what we're comparing it to, can be animated, which kind of looks like having the line animate bottom to top because we're comparing it to different values with the same threshold, okay? So there's the main idea. So now we have thickness and we have position. I think the next order of business after we pick a good thickness, maybe divide this by 2. By the way, you can just type in math expressions in here. Divided by 2. Next order of business is even though we have this nice and animated, or we could animate it, it's kind of like very boring. It doesn't have any of that distortion. It doesn't look like fire. And that's probably the next thing that we should tackle. So again, what do we have here? We have UV coordinates being separated so we can extract the Y value that we're then doing some math for to make this line. If we want to distort it, it would make sense that we go back to the beginning. We kind of mess with everything in here so that all the steps remain the same. It's just that we're feeding different texture coordinates into it. This is another trick I talk about all the time. We're going to use noise texture. Why? If we want to add noise to our texture coordinates, what easier way is there than just adding in a noise texture? It makes sense. And we're just going to add these two. So we're kind of contributing information from both of these. So let's make it vector math. Boom. And you could use factor. You could use color. The difference is factor has the same for x, y, and z. It's a kind of like a one-dimensional value that's mapped to the entire vector. And color should have different stuff for x, y, and z. It really doesn't matter. I'm just going to use color since technically it has, more information. So what have we done here? We've taken UV coordinates added. We say contribute the noise textures. Now we have noisy UV coordinates, and it looks really weird, and we could animate it and all this, but it doesn't really look like our line from before, and this is because, and here comes a bit of an explanation. So get ready. What the noise texture is it maps to every point on our plane. We have a noise texture. Every point on our plane is going to have some number between 0 and 1. That's determined by the noise texture, and we're adding it everywhere because we're adding it to the UV coordinates, which means that on average, we're adding 0.5 on the x, y, and z because everything's 0 to 1, which means overall you add infinitely many points. On average, we're adding 0.5, which means that on average this is shifting the texture. It's shifting the texture by 0.5, 0.5, 0.5. So to fix this, we just subtract the vector 0.5, 0.5, 0.5. And now you can see this is kind of centered, and if we affect the scale, you can kind of see how our line is hidden inside there. So again, we contributed the noise texture to make it noisy UV coordinates, and then we just added this correction term. Now, of course, this looks like really hot garbage, and what people use this for is they always set this to a giant number, which makes it look like a blurred version of whatever you had before. So this is just a blurred line. A manipulation I like to do on this is instead of just feeding in noise texture and doing discorrection, I want to control the strength of it, which is going to let us kind of restore some of that line. Okay, how do we control the strength of it? Well, this is kind of a vector quantity. Even though it's not purple, it has x, y, z components, meaning we can add a vector math node, set this one to scale, meaning a scale for our noise texture, a strength, a magnitude. How strong is the noise texture? And we could set that to 0, at which right now is going to show nothing because of the correction term. If you set that to 0, it will restore, but we have a scale value here, and if we were to manipulate this, make the noise stronger or weaker, that would mean we also have to correct the correction term, because this 0.5, 0.5, 0.5 is dependent on this number being 1. If it's anything else, it doesn't work. So I'm going to actually add another vector math scale node connected here, and we want to subtract 0.5, 0.5, 0.5, but we're going to scale, again, our correction vector by the same number. So value node, connect, and there you go. So again, we now control the strength of our noise. Let's say it's a 0.5 strength, that's half as strong, and to compensate, we make our correction vector also half as strong. So when this is set to 0, we have our line, and when you increase, it's just going to distort this nicely. Okay? And you can see that's a better result than what we had before. And even better is once we kind of pick a level of distortion, it works with everything following, because this is just a manipulation of the texture coordinates, all this stuff. And then it does that Y component thing, meaning we can go from top to bottom in the same way. And because we can control the quality of our noise, we can control the quality of our noise, we can make it look more fiery. So detail, make that maximum. So now we have those very jagged edges that we didn't before. And the real trick to fire is roughness. You want to set this high, which kind of makes it look nice and scattered. And we can increase the thickness of this. Again, the epsilon is the threshold for comparing. We can make this thicker, which has a thicker burn line. Okay, cool. So now what do we have? We have a nice setup that lets us do this kind of thing. I'm thinking add a bit more distortion. So something like that. and a little less roughness. We can play with this a bit later, of course. More roughness than this. Okay, this is our setup. Next, I think we should probably talk about how to, take this and make it look like it's glowing, not just this black and white thing. So we want to have this on top of our texture and make it glow. Okay, how do we do that? Well, first of all, I don't want to feed this image directly into the surface, even though that's fine. I want it to react to lighting conditions, especially if we have emission and all that. Let's use a diffuse BSDF. So now it's the same thing, but we're just feeding it through a BSDF, so it reacts to our light source. You can see it's changing. And then what we're going to do is we are going to add a mix shader. We're going to mix this with a emission. Why? Because we have our paper, and on top of it we want emission, we want glowing, and that glowing is going to be determined by this mask that we made. Okay? So this is going to be, let's say, the color, which so far looks like this. So now we have the paper with this on top, and we can control the brightness of this, which kind of looks weird because we don't have bloom enabled. So enable bloom, and now it's going to start glowing. And on top of that, we can also use I guess there's a couple ways to do it. We can use a color ramp to change the color from white to, I don't know, red or orangey, something fiery. And now we have a nice setup that lets us control the brightness of this fire. We can make it ridiculous, and we can also animate this thing. And we'll kind of mess around with this once we have more stuff working to see what actually looks good. Okay. Next order of business is actually having it, in some sense, disintegrate the paper. What I mean by this is we should have paper here, and then back here where it's already gone through, it's already burned through this, it should be transparent, it should be gone. So, again, what we're doing is to get rid of the paper, we're faking it by saying make that area transparent, as if it's already been eliminated. To do this, what we're going to do is before we do the mix shader with the emission, so under the emission, what we want is another mix shader. We're going to add a transparent BSDF. And then we want to say, okay, Blender, make this paper transparent where? Well, probably not this thing right here, because this just says where the fire is. What we want is the region under it. And you might think, oh, this is going to be very complicated to do. Not really. All you need is another math node. Set it to, I think, greater than, or maybe less than. And all we're going to do is we're going to feed in the same data. So we're going to see where's y. Again, we're using y. Where is y greater than, let's say, the same value. So we could either put that in manually, so 0.6, which looks like this. I guess this gives us the region above. So, I mean, we can work with that. Either way, it gives us a region either above or below. We could either put in the number manually, or what makes more sense is use a value node so we can animate both at the same time. Okay, so now we have a where the paper exists mask and a where the fire is mask that move together. Okay, and what we want to do is we want to say, I guess now we want to switch these. We want to say use this greater than for the transparency mix shader. This is so okay. Let's take a step back here. What's happening? We start off with our paper, which we're feeding in through a diffuse BSDF because we want it to react to lighting. Next, we want to say, Blender, some of this paper needs to be gone. It's going to be burned. It needs to be transparent, which gives us this, which right now is black, but we'll fix it. But either way, you can see this paper is now burned, and then on top of it, we slap on the fire. So there you go. Now you can see we have a very nice setup that lets us control how much of this paper is burned in a very kind of logical way, where we can also control the kind of type of fire, and everything just kind of works together. And this looks really good, actually. Okay. I got a bit enamored there. It looks so good. Okay, so where are we? We've done all this. I think we want to actually make this transparent instead of black. And the reason this is an issue right now is by default, Eevee's transparency is kind of fucked a little. And that's because in the material settings, you need to go to, what do you need to go to? You need to go to settings, blend mode, set it to alpha blend, which is basically going to tell Eevee wherever we say it should be transparent to actually do that and make it transparent. And right now, we should probably set film to transparent as well, so that we don't see any weird stuff. And yeah, okay, there we go. So now we have a very nice setup where we can see the burning and all this. Another thing that might be useful, and this is actually just a quick addition which lets us get a bunch of control. I talked about rotating the fire. So do we want it top to bottom, left to right, whatever. And we don't want to just say, oh, now use X coordinates instead of Y, or some combination of X and Y. We want a nice way to manipulate this before it reaches this step of the shader, which means, of course, we're going to be manipulating in here. We're going to be changing the texture coordinates before anything even happens. And to do this, I'm going to use a vector rotate node, which I think is 2.83 and above, which is why I said use 2.83 and above. And this angle is going to let us change the direction of the fire. So let's say we have like 32 degrees. You still use this in the exact same way. Okay? It's just that we rotated it. So maybe I'm going to have it go a bit to the side, something like 10 degrees, like that. And that's going to be our kind of thing. Okay. Next order of business, before we make the fire look even better, is I think one final touch that I always like to add is if the paper is, like, let's say right here, very close to the fire but not yet consumed by it, it should kind of be getting darker, kind of like charred, until the fire kind of sweeps through it. So it's kind of this like aging process of the paper. And it's actually very easy to do because we already have nodes that describe where this fire is supposed to be. We're going to do a bit of a manipulation, but basically, the idea is before this texture is even fed into the diffuse BSDF, we're going to use a mix RGB. So we're going to say affect the color of this texture. We're going to say make it kind of reddish, orangish or something, which you can see we can control the strength of. And for the strength, we're going to create a mask just for that. And we don't really want to use the fire mask because that is directly under the fire. You're not actually going to be able to see anything unless you make a version that's a bit thicker, right? But this is a 0-1 map. It doesn't have any nice fading or anything. It's either 1 or 0. So let's make a nice fading map. To do this, what I like to do is I say instead of compare, which does this whole threshold thing, and it either says it is within the threshold or not, 0 or 1. What we're going to do is we're going to make a gradient version, which is going to use subtraction. So we're going to say y values. Are you within, or really we're going to compare it to the same value as before. So really we're using y 3 times. And we're using our value 3 times. And in each time, we're kind of comparing these two values in different ways. One of them we're saying greater than. One of these we're saying, a compare, and one of these we're saying a subtract, which should have a nice gradient, as you can see. So we're going to subtract this, and then we want it to be a distance. So we use absolute value, because the real number metric for distances is absolute value, x minus y. This is a mathematical thing. If you don't get it, don't worry. But what it's going to do is it's going to output the distance from the value from our y coordinates to the value that we have decided over here, which preserves the noise because it's back here, which looks good. But if we were to use this as the mix factor, it should look like this. It's actually very weak right now, which is kind of the issue. So what we want to do is before it even reaches here, map range node, which is going to let us kind of control this fall off. So map range, kind of either push this in or push the other out. I can't ever remember which it is. Yeah, I guess it's this one. Like that. And then we just want to invert it, which I think we could either do a 1-0. Yeah, 1-0 inverts it, because we're, instead of mapping initial interval to 0-1, we're now mapping it to 1-0, so it kind of flips it. I think this is probably a fine way to proceed. So again, paper, manipulate paper, make it diffuse, make it transparent below the line, and then make it glow on the area where it's supposed to glow. And you can see that now we have a nice way to control, using this map range node, how much of this we want burned. And looking back, we should probably make this darker, like that. So let's see. So now what we have is a single slider controlling the progress, and you can see this paper kind of gets burned before it even reaches that area. And one thing I'm seeing is this fire. Now let's make the fire look good. This fire looks like garbage, so let's pick a better color, and let's make it maybe desaturated, so it looks kind of like a wider, brighter flame, I think is what's going to make it look good. Yeah, there you go. And I'm thinking that this is still charring a bit too much in advance. So how do we manipulate this? Map range node. Like that. There you go. And then finally, let's just mess around with our fire until we like the look of it. So this is maximum roughness, by the way. It kind of has this very scattered effect, so it's a bit too much, but you just want to play around with this. So this kind of gives you a very distributed fire, which kind of doesn't really work the way you'd expect to. So you have this hole in the fire, but then it kind of, I mean, it doesn't look that bad actually. But I don't really like the way this is burning. It doesn't make much sense. So I'm going to go for something like this, top view. That looks pretty good. And again, we can always control the rotation, the quality of the fire being, you know, this noise stuff, the distortion, and a bunch of other stuff. I think final thing is we want to automate this animation, because we don't want to, you know, put keyframes in this value node. That's a lot of work. We don't want to do a lot of work. So what I like to do is you're going to notice that when we set this to 0, it's as if it's like just beginning the scan. It's right in the corner. And then you keep going a little, probably to 1, a little past 1, because we scaled up the plane and there's a good amount of distortion. So what I'm going to do is I'm going to use a driver, which we can either, you know, automate or not automate. We could do it manually by add driver or whatever. So we'd want to copy the frame number as a driver, or a fast way to do this is a tag frame. So this is saying make a driver that looks at this frame number, which right now is going to be too fast because it's immediately going to 1, and then it's going to be 2, 3, 4, 5, 6 as we go up the frames. So just kind of divide this by some number. So 60, it's going to go 60 times slower. And if you want this to be faster, you could have it go 30. So now it's going to be twice as fast, and really you can decide what you want here. In fact, you can make this a mathematical expression. So we're using this just has the frame, and then what we do is we divide this by some number that we can decide after the fact. So like 60. Let's redo that driver. Frame. There you go. So now we can control the speed of this as it's even playing, which is kind of an interesting idea. But yeah, I think that's kind of the essence of the tutorial. Of course, there are ways to make it look a lot better, but the core ideas are here. This rotation, this messing with texture coordinates, this math, this, I don't even know what's going on anymore. Anyways, I hope you enjoyed this paper burning tutorial. I thought about making this a Patreon exclusive, but no, this one is for the public. And speaking of Patreon, if you want exclusive tutorials, if you want to support this channel, if you want behind the scenes Discord access, blend files, etc., Patreon is the way to do that. It is the kind of only thing that keeps this channel going in a non-volatile way. So I super appreciate anybody who's a patron, and hopefully you don't only want to donate but get that stuff in return. I try to make it worth it. But yeah, that's the thing. I hope you enjoyed this free tutorial. Patreon in the comments. Other than that, thank you for watching. This was a good one. Very explosive, fiery.